So then I can start with my presentation. Judith kindly introduced myself, so I don't have to do that again. Try to get to the next slide. So what's the problem? Why do we want to analyze the fertilizers in organic horticulture? We work a lot with animal husband, works a lot without animal husbandry. Therefore, we are strongly dependent on external commercial fertilizers. That means that we have or need contentious inputs from conventional farming. That's, for example, feather meals, pig bristles, or manure from intensive conventional animal husbandry. But also we need or use products from conventional or from conventional origin, like for example vinasse, that may contain contaminations with plant protection products. And also we have the risk of nutrient imbalances. That means that the nutrient outputs by the harvested products is not the same like the nutrient inputs of the fertilizers. That means that there is a risk of K depletion and excess of P inputs. Therefore, we need alternatives. That means that we need sources from within the farm or external fertilizers that are non-contentious. What are the solutions? For example, we can use clover grass based fertilizers from the farm itself or from other sources that are vegan and are from organic origin. Like for example, on the top left there we have clover grass silage, and on the right side we have then we can use digestates from organic origin or from household waste, like Caspar told us before. So we can close the rural urban nutrient cycle. On the right side, I have two pictures of the biogas digestates we use. Yeah, they look quite similar to each other. Then we have could use residues from the organic food industries. For our example, you can use tofu whey from a tofu production company here in our region that's also vegan and of organic origin. Then to our trial, we have two experimental years from 2019 and 2020 with a 2-year crop rotation. And we want to take a look at the whole system, so we have a system approach. Our crop rotation is we have an early white cabbage for direct consumption. After that, we have a spinach, and then following, we have a winter wheat for baking purposes. In total, we have 8 treatments, that means fertilizers, and the fertilization was based on the requirements of the cabbage. That means that it based on the mineral N content, we supplied 220 kilogram N per hectare. The treatments are, we have a control with no fertilization, then we have a horn grid, more or less like a second control treatment here. Then we have a silage, clover pellets, biogas digestates from a clover grass and pig slurry, then tofu whey, farmyard manure, and biogas digestates of the bio-waste. First of all, I wanted to show you a graph, a table of the nutrient contents that are from 2019. First of all, it's quite interesting or quite good to know that we have a tofu whey that has a quite low TS content. So that means we have a lot of water that we have to bring on the field compared to the other fertilizers. It's also interesting that the composted farmyard manure has the highest content of calcium, kalium, magnesia, and P in comparison to the other fertilizers we used. For the just for the C content of the biogas digestates, it's for the bio-waste one, it's quite interesting that we have a lower C content compared to the other biogas digestates. That's more or less because we have used a separated biogas digestate. Just keep that in mind. Then to the results, I just show you results of 2019. but from the whole crop rotation. Just in the top corner on the right, just to make sure what our definitions are. We have the marketable yield. That means that the cabbage heads are bigger than 1 kilogram. And then we have a non-marketable yield. That means the heads are smaller than 1 kilogram. On the left side, we have the total yield. That means that we weight the whole biomass from the plot. There you can see that there is just a significant difference between the control and the other treatments. Within the fertilizers, you can see that Horngrid had the highest yield, total yield. But the other fertilizers haven't been significantly different. When you look at the marketable yield in the middle of the graph, the Horngrid had the significant highest yields compared to the other ones. But you can see that the clover pellets, it's the black one with the white dots, and the one next to it, the biogas digestates from the clover grass, are also quite good. For the non-marketable yield, the control had the highest non-marketable yield, so it had the smallest heads, but the overall, there was no significant difference between the treatments. Next to the spinach, here you can see that the produced the highest yield over all the treatments. The control, well, as expected, had the lowest yields. Yes. Then to the winter wheat, we couldn't find any significant difference between the treatments. Just to let you know that the error bars are the standard error and not the standard deviation, so maybe it is a little bit confused. But you can see that overall the Horngrid tends to have the highest yield in comparison to the other fertilizers, but they are not that different to each other. Now I come to my conclusions. The first preliminary results show that all fertilizers are suitable as alternative fertilizers for the organic horticulture without high yield losses, especially when you compare it to Horngrid. Then the clover pellets and the biogas digestates of clovergrass and pig slurry seem to be the most promising alternatives. Yeah. But keep in mind that we have to, we need a second year to verify the results. And we also have to do a detailed evaluation of plant and soil samples. Then there are some problems for us. For example, for the clover pellets, we have to buy them and the costs are quite high. And is it really worth to buy that? That's why I made a calculation for clover pellets for 1 kilogram N. You have to pay 81 euro in comparison to Horngrid, where you just pay 12 euros per kilogram nitrogen. So is it really worth to pay it? Or maybe if more farmers will work with it, maybe it gets a little bit cheaper. Then the tofu way, as I mentioned in the beginning, is it really worth to transport all the water because like 97% of it is water? Or is there a possibility to reduce the liquid fraction without losing any nutrients? So maybe it would be interesting to talk to the tofu whey production company. Maybe are there some possibilities to do that? And also for the biogas digestates of biowaste here in Germany, they need to be EU organic certified, and it's quite complicated to get these biogas digestates that have this certification. So then, thank you for your attention.